This is part 5 of section 6.5. We want to find the projection of V onto W. I need to find V dot W. Here, remember that if you just have J, this is the same thing as 0I plus J, 1J. So 2 times 0 is 0, plus 7 times 1 is 7, so this dot product is 7. I need to find the magnitude of W squared, and that is 0 squared plus 1 squared, which is just 1. So the projection of V onto W will be 7 over 1 times W, which is 7J, which is the vector 0, 7. Decomposition of a vector. In many applications, it is desirable to decompose a vector into the sum of two orthogonal vectors. And it's fairly simple to do that. Any vector V can be written in the form of two vectors added together, where the first vector is parallel to V, and V2 is orthogonal to the other vector, W. We let V1 be equal to the projection of V onto W, which we've already talked about how to do. And then we find the second V part, the V2, by subtracting them. Okay? This is called the decomposition of V with respect to W, and V1 and V2 are called the components of V. If I want to decompose V with respect to W, V1 is equal to the projection of V onto W, which is V dot W. This will be 0, 1 as a position vector. So V dot W over the magnitude of W squared times W. V dot W, 4 times 0 is 0, plus negative 3 times 1 is negative 3, over, this will be 1 squared, which is just 1, times W. So this will be negative 3W, which is negative 3 times J, which is 0, negative 3. Okay, now to find V2, we take V minus V1. So this will be 4, negative 3, minus 0, negative 3. And we subtract component-wise. 4 minus 0 is 4. Negative 3 minus a negative 3 is 0. So the decomposition of V is V1 plus V2. Okay. Similar problem here. We want to find the decomposition of V with respect to W. So we're going to find V1, which is V dot W. So 5 times 3 is 15, plus 2 times 5 is 10 over the magnitude of W squared, which will be 3 squared plus 5 squared. Okay, this gives me 25 over 34. Oh, and this is times W, sorry. Parentheses times the vector W. Which means that V1 is going to equal 25 over 34 times 3, which is 75 over 34. 5 times 25 over 34 is 125 over 34. So that's V1. To find V2, we take V minus V1, so 5, 2 minus 75 over 34, 125 over 34. And subtract, getting common denominators. And you get that 5 minus 75 over 34 is equal to 95 over 34. And 2 minus 125 over 34 is negative 57 over 34. So the decomposition of V is V1 plus V2. So 75 over 34, 125 over 34, plus 95 over 34, negative 57 over 34. Okay, just one more topic. It's work. The work done by a constant force F, which is a vector, moving an object from a point P to a point Q, is defined by work is equal to the dot product of the vector F and the vector PQ, initial point, terminal point. And we also know that this dot product could be written as the magnitude of F times the magnitude of this vector, cosine of theta, where theta is the angle. So we're going to be asked to find work by various things, and we may be given an angle, we may not be. Okay? Let's look at an example problem. A force F is equal to 64I minus 20J, and that's in pounds, is applied to an object. The resulting movement of the object is represented by the vector D. This is playing the role of PQ. 10I plus 4J, and this is in feet. Find the work done by the force. Our work is going to equal our vector F dot the vector D. So 64 times 10 is 640 plus negative 20 times 4, that's negative 80. And that gives us 560. And these are measured in foot-pounds. Foot-pounds. And that's your answer there. Okay? A vector F represents a force that has a magnitude of 10 pounds, and 2 pi over 3 is the angle for its direction. This refers only to F. Okay? It's not the angle between the two vectors that we're talking about. It only belongs to vector F. Find the work done by the force moving an object from the origin, 0, 0, to the point -6, 3. Distance is measured in feet, and round the answer to the nearest integer. This is also going to be in foot-pounds. There's pounds, feet, foot-pounds. the first thing we need are vectors for F and for our other PQ or D in this position, basically the distance that this moves, okay? To find the vector F, we need to use the formula from the previous section, okay? F is going to equal the magnitude of F times cosine of that angle, 2 pi over 3i, plus sine of that angle, 2i over 3j. Okay? So this is equal to 10 times, I'm going to go ahead and write this as a position vector. This will be cosine of 2 pi over 3, sine of 2 pi over 3, which is 10 times cosine 2 pi over 3, 10 sine 2 pi over 3. Yes, we know these exactly, but you're not going to know them on all of them, so I'm leaving it like this just so you can get a feel of what it's going to look like when you don't know those specific values. Now, the way we find the vector here, that vector D is going to equal -6 minus 0, 3 minus 0. Terminal minus initial. So this is the position vector, -6, 3. And anytime you're moving from the origin to a point, the point and the position vector are going to have the same values. Okay? The work done by this is the dot product of your two forces. So this will be -6 times 10 cosine 2 pi over 3, which is -60 cosine of 2 pi over 3, plus 3 times this, 30 sine of 2 pi over 3. And if you did not know these exact values, you would go to your calculator and get an approximation, but we do know exact values here. Cosine of 2 pi over 3 is -1/2. Sine of 2 pi over 3 is the square root of 3 over 2. So this is exactly 30 plus 15 square roots of 3. And they want us to round this to the nearest integer, so if you go to your calculator and plug it in, your decimal approximation is going to be 56 foot-pounds. And we have finished the last lecture of the last section of this course.